here someplace. That's not even half of a half-life. So what should we do with all this waste that we have right now?
So what we're about to do, I think, is amongst the worst things that we can do, which is to move ahead with a project that we know technologically can't contain the waste. So what we should do, and most independent experts believe this is what we should do, is that the high-level waste should remain at the site of generation, the reactors, for 50 to 100 years. It needs to cool off anyway before you can handle it more safely. And during that time, intensive research to come up with a better way of dealing with it than just digging a hole in the ground and putting it there. It's hard to conceive of a technology more dangerous and a species less capable of handling that danger.
Good evening. My guest is Congressman Peter Newton, and the topic is nuclear energy. Congressman, what about the fact that reactor-grade plutonium could be used by terrorists to make weapons?
Well, that's bad. So I would have to say I am against nuclear energy.
But you could also argue that in over 50 years of using nuclear energy in the U.S., no one has ever been killed in a nuclear power accident.
That is good. Count me in on that.
And then there's the enormous cost of disposing of nuclear waste.
We cannot afford that. Nuclear power has got to go.
But if it does go, we'd lose the source of 20% of our electricity here in the U.S.
Exactly. There is no way I'm going to tell the good people who elected me to use 20% less electricity. Read my lips. We need nuclear energy. Period.
Let's try this. Gum tastes good.
I have always stood up for gum. They will never take gum away.
$300,000 tons and growing. Scientists have spent nearly 60 years and billions of dollars researching and testing, looking for a solution to this problem. They've come up with some pretty interesting ideas, like burying waste under the ocean floor, dropping it into a hole in the Earth's crust, tunneling under remote islands and leaving it there, or stashing it in the polar ice caps. So far, all these plans prove to be unmanageable, too expensive, or just too dangerous. But what about shooting the waste into outer space? We would be rid of it forever, and it could just fall into the sun or maybe expand with the universe. Why don't we just take this nuclear waste and shoot it into space on a rocket?
If you look at the space shuttle program, which is one of the safest programs in space travel we've ever put together, we've had 2 accidents in, 200 missions? You're looking at 1 in 100. The average payload on the space shuttle is a few tons. We're talking about sending 70,000 tons of material up. You're going to have an accident. Imagine, you know, the fervor that's going on now, and we're talking about moving this material across country and disposing of it deep underground in our own country. Imagine the fervor if a few tons of this material was dispersed in a fine powder in the upper atmosphere all around the world.
Be a problem.
And
it would be a mess.
That's really the main reason, and not to mention the cost.
Now, what is this business of transmuting?
Basically, the common adage or the age-old dream of turning lead into gold. We take something that has a negative value and turn it into something that'll go away, that'll either decay away within 30 years or 100 years or turn into something stable.
Let's say this is the arrangement of fuel rods in a nuclear reactor. To get rid of nuclear waste, it's been proposed that we build a different type of reactor where the reaction is more spread out, using fewer fuel rods or less concentrated ones. Now, this reactor wouldn't sustain its chain reaction, but if we could blast it with a powerful enough beam of neutrons, We could get these elements to change or transmute into lighter, shorter half-life, less radioactive elements within a few hundred years. If this works, it would be possible to transmute our high-level waste into low-level waste, and then we could bury it safely within a century or so.
Right now, when you look at Yucca Mountain or any other repository in the world, you're dealing with managing elements for hundreds of thousands of years, beyond the scope of human knowledge. If we can get that number down to 1,000 years, we can look at examples. You look at the pyramids, look at the ziggurats. We can see concrete examples of human engineering that's lasted for thousands of years. The question is, do we spend money now to reduce the potential problem in the future? Or do we feel that potential problem in the future is small enough that it is not worth spending resources now? You're talking about taking money from researching cancer cures. You're talking about taking money from schools or your tax refund and putting it towards getting rid of a problem that some people don't think is a large problem.
Nuclear power offered great promise. It was created by geniuses, but there are no genius trash collectors picking up after them. Right now, the nuclear waste problem has no solution. Yucca Mountain is fraught with difficulties. The state of Nevada is doing all it can to stop it. See, nuclear waste has been sitting out there all over the world for decades. But remember, we're talking about plutonium and very concentrated uranium. This stuff is deadly on a scale that's hard to imagine. You have to wonder, has anyone really stopped to think what 10,000 or 30,000 or 300,000 years really means? No civilization in history has lasted a tenth of the half-life of this material. And until the waste problem is solved, for real, nuclear power doesn't do us any good. Future generations, 100 or 200 years from now, our descendants are going to be furious with us. So solve the waste problem or shut the reactors down. Now, you're a voter or a taxpayer. Make them get it done. That's the way I see it. And I'll see you next time on The Eyes of Nye.
We've covered a lot of ground, but it's just the tip of the iceberg. Check out eyesofnye.org for more cool science.